any profession, understanding your role is imperative to success. However, VDC is a constantly evolving career, so its scope of duties may seem ambiguous to a person that is new to the field. This video will help you understand the current landscape of VDC responsibilities and how different software and workflows are utilized to achieve them. As a VDC engineer, your role is to ensure that project requirements are met, collaborate with stakeholders to ensure effective communication, implement lean construction principles, and monitor project progress. The first step towards success is to understand the project requirements. You should work closely with your team to identify project goals, scope, and constraints. Your team members will be vital to helping you execute your deliverables, so be sure to have a conversation with those who understand the approach your team will be implementing. Review all available project documents related to the scope of work so that you can be sure that you're including all required information. Understanding the project documents will also help give you insight into how VDC can be applied to provide additional value. Building information modeling tools are essential for VDC engineers. They allow you to create 3D models of the project, visualize designs, and coordinate between different trades. There are many BIM tools to choose from, but some of the most commonly used are Revit, Navisworks, and Synchro. The better you understand these tools, the more efficient your work will be. Collaboration is key to success. You will work closely with project stakeholders such as architects, engineers, contractors, and owners to ensure effective communication and coordination. VDC engineers must be able to clearly communicate technical information to those who may not be familiar with computers or technology. Remember to always be as clear as possible to avoid confusion and miscommunications. VDC and lean construction go hand in hand. Lean construction principles aim to reduce waste, increase efficiency, and improve project delivery. You should strive to implement lean principles into your processes. As you progress through your career, you will increase your ability to find value and opportunity through lean. VDC tools can provide real-time project data, allowing engineers to monitor progress and identify potential issues. By analyzing project data, you can optimize processes, reduce costs, and improve project outcomes. When compiling data, it is essential to have a clear and easy-to-understand file structure and not to deviate from it. This will ensure that all the building information is readily available to all parties. Engage in continuous learning. VDC is a rapidly evolving field, and as a VDC engineer, you should continually seek to learn and stay up to date with the latest tools and technologies. You can attend conferences, workshops, and training programs to improve your skills and knowledge. Without the drive for continuous learning, you will fall behind on the latest workflows, capabilities, and technologies, which will make you less competitive compared to others who stay plugged into the latest industry developments. You will need to utilize a wide range of software and techniques to perform your tasks effectively, including BIM software for 3D modeling, clash detection, quantity takeoff, construction planning, simulation and visualization, and quality control. Let's take a brief look at each of these tasks, the software used, and their applications. 3D modeling. There is a variety of BIM software available to create 3D models of construction projects. Revit, AutoCAD, and SketchUp are commonly used for 3D modeling. These programs will provide you with the ability to create and manipulate detailed 3D models. You will need to use these models to collaborate with architects, engineers, and other stakeholders to ensure that the design meets the client's needs and complies with all applicable codes and regulations. Clash detection. VDC engineers use BIM software to identify potential clashes and conflicts in the design phase. Autodesk Navisworks is the most commonly used software for design conflict identification and resolution. These software programs enable VDC engineers to combine 3D models from multiple sources and identify interferences, conflicts, and other issues, allowing them to resolve these problems before the construction process begins. You will need to run a clash detection analysis to identify any potential clashes between the different systems. You will then have to coordinate with the trades to resolve each of these issues. By resolving these issues in the design phase, the team can avoid costly rework and delays during construction. Quantity takeoff. VDC engineers use BIM software to accurately calculate the material quantities required for construction. Software such as Autodesk Quantity Takeoff, On-Screen Takeoff, and Bluebeam are commonly used to achieve this. You will need to input the dimensions of each structural element, such as concrete footing, steel beams, and asphalt paving, into the software. It will then calculate the required quantities of each material, helping the team to plan and manage the construction process more effectively. Construction planning. VDC engineers use BIM software to create 4D models, which include detailed sequencing of construction activities. Synchro is a software commonly used for this. You will need to link each activity, such as pouring concrete or erecting steel, to a schedule that you will upload into the software. The software will then create a simulation of the building being constructed from start to finish. This information will help the team visualize the construction process and to manage the activities more efficiently. Simulation and visualization. You will use BIM software to create simulations and visualizations of construction projects, which can help stakeholders get a better understanding of the building environment and aesthetics. BIM softwares such as Autodesk 3ds Max, Twinmotion, and Enscape are commonly used for simulation and visualization. You will first use these software to create the simulation, including its interior spaces and exterior facades. You'll then use your simulation to create detailed logistic plans or other pursuit deliverables. Quality control. You will need to use BIM software to monitor and control the quality of the construction projects. Autodesk BIM 360, PlanGrid, and Procore are commonly used for quality control. These software programs enable VDC engineers to monitor and control the quality of construction projects by providing real-time data and enabling collaboration between project stakeholders. You will use them to track the progress of each construction activity, including inspections and testing. The software will then provide real-time data on the project's quality, helping the team to identify and address any issues before they become major problems. By understanding what is expected of you, how to achieve your goals, and how to communicate information effectively, you will excel at your role in VDC. As your knowledge and experience grow, you will be entrusted with more critical and complex tasks. But don't worry, we will be posting in-depth videos on each of these topics and many more, so hit that subscribe button and take a look at our other videos for more VDC content like this. If you found this video useful, go ahead and hit that like button. And if you want to learn more about VDC and BIM, then click that subscribe button and notification bell. Thanks for watching.